Okay, then we have a problem of finding triples. We are given a list of numbers like this, and we want to find how many triplets we have that for each middle there are left and right positions that has the middle times 2. Like in this case, it's one triplet, and the second triplet would be is this 2m in the middle. So this is a like prefix or suffix frequency counter type of problem. We for triplets it is always or very often efficient to go from the middle, especially if we have such symmetry for the left and right. So we have the middle, and for the left and right it is the same kind of number, it's 2 middle. So let's consider the middles, and for every middle, for the 3 for example, we want to find how many 6 we have in the left and the right. And to count triplets we just have to multiply left by right counters, and that would be total number with this current middle. So it kind of simplifies our problem to find just the frequencies of the left and right. However, to find these frequencies, you have to think a little bit, and this is also not very hard. Like, let's consider some numbers, and let's consider only lefts. So the lefts is very simple. We just go, and as we go, we compute this frequency of x plus plus. This would be counting on the lefts. And to count the rights is also not very hard. We can pre-compute all the array in total frequency, and the right would be total frequency minus left. So this is kind of the trick, and it's not very hard to deduct it yourself. And just one single corner case, you have to exclude the middle from the counter, so you should be careful. Count the left, then you iterate to plus plus, and then you do the minus operation to count the right. So this is two-pass solution, and it is accepted. It is of n time complexity and of n space complexity. However, of course, there is a Lee on the LeetCode, and he has a wonderful solution of single pass. And it's kind of very clever. So consider like some numbers, I don't know, like this maybe. And when we going from position, we only doing single pass, so we should have all the information to on the left to efficiently compute all the rights in the future. So for the current left position, what we know, we can find the frequency of all the numbers, and what else? For example, we can look at how many edges we has and compute them too, like like this. And when we meet the next like 8, how can we know about this triplet? So we should know that there are some 8 to the 4 pairs and count them. And let's so if we know how many 8s we have, so we I would it would look like this. The 8s we have is f by 8. This is how many 8s we have. But C is the counter of how many pairs we have. And this would be actually like C4, I would say. So if we meet another 4, we should know how many 8s we have before. And if we have like some 8, we do it like this, plus equal. So C4 is plus equal F8, the frequency of 8. And when we meet the 8, we do this kind of result plus equal this C8 divided by 2. The corner case is that you have to check if the current number is actually divisible by 2 before you're doing this kind of operation. So let's look at his description. It's kind of not very obvious, but it's obvious if you read it slow. So let's look at the code. Maybe it's just better. So it's C1 and C2. C1 is just the frequency counter, nothing special. But C2 counter of this kind of pairs of, and like this, like 8, then you meet 2. It's kind of one pair, C2 plus plus. And when you met another, like 4, you do this again, how many 8s we have, and doing this like again, C2 plus plus. So am I correct? So C2 plus frequency of 8. Am I correct? Yes, I'm correct. So C2 plus equal frequency of 8. This is C2. And this is like X. This is 2X. Yep. This is how it's made. And this is a single pass solution. It's slightly better. You can use hash map, you can use just integer array. It's kind of big, but it is still very efficient, even if it's big. So that's it for today.